Hello everyone. Today we're going to go ahead and learn about angles and their measures, and specifically what are angles, right? So what I want you to do right now is use what you already know, whether it is from geometry, physics, or whatever the case may be. I want you to go ahead and match these angles, right? These angles A, B, C, D with these numbers 1, 2, 3, 4. So go ahead and pause the video and give those a try. What would you say are their match? So pause the video, give it a try. Okay. So let's go ahead and look at all these pictures. So if I see this angle right here, it's right on this little axis and this little axis right here. So it looks like it's just one quadrant. And we can go ahead and see that this right here would be a perfect perpendicular intersection. So this is most likely a 90-degree, right? Because we can see that from here to here, it was 90 degrees. Alrighty, B on the other case, we can go ahead and see that it's still on its axis. However, it's not complete. It's just, it's more than 90 for sure. But we can see that if this right here was 90, so from here to here was 90, and we did it again, right? This is another 90, and one more, we did 93 times. So 90 plus 90 plus 90 gave me my 270, right? Assuming that all these are perpendicular lines, right? Okay, what we're gonna go ahead and see next is this one right here. So this one's a little bit tougher to see, so I'm gonna go ahead and rely on the multiple choices. And I'm gonna go ahead and see that the only one that is less than 90, right? Because this right here is 90 degrees. The only one that is less than 90 would be this right here, this option that they told us it was 60. Okay. Last but not least, I made this other one to have to be more than 90, right? Because this was right here. We saw that quadrant number 1 is 90, but it goes a little bit more. So the only one option here would be that this should be 150 degrees. Okay, so this is how we were able to match it based on what we knew from right triangles. I'm sorry, from right angles and stuff like that. So process and elimination and all that stuff. This is from my live class. Okay, so today we're going to go ahead and learn what are angles, how do they work, and can we convert degrees to radians. Sorry about that. Okay, so basic characteristics of angles. So what I want you to know right here is the following, that angles themselves are always, well, most of the time are always in standard position, meaning they're like similar to the X and Y that we tend to use when we're graphing. But if the initial side right here is on what you guys would call the x-axis, this right here is a standard position angle, right? It's in standard form, a standard position. Okay, so this right here would be its initial side, right? This right here. And the angle is measured from here all the way to where it stops, and that is called the terminal side, where it stops. Okay, here you'll either have some sort of theta that will tell you that this angle is either in degrees or radians or whatever the case may be. Okay, and last but not least, you see this portion that looks like a circle, somewhat of a section of a circle. That is what we call an arc. So these are pretty much what you need to know about an angle. And you can go ahead and write it. Well, you should write this down in your notes, but it doesn't have to be as pretty as this one right here. Or it does? Who knows? Just kidding. All right, so let's go ahead and continue. If you didn't finish, pause the video right here so you can finish drawing this diagram. Alrighty, so next question is, okay, cool, I found out about angles, but what do they do? How can I measure them? So, well, actually, yes, we can measure them, and there's two different forms. I know now it's not as common to look at clocks, but counterclockwise will give us positive angles, right? Counterclockwise, meaning against the clock, and then negative angles will look clockwise. So if you have no clue what that means, it's probably because we all tend to look at the digital clocks, but that's okay. Pretty much this is what it means. From the standard position, if I go up in this direction, this is going to be a positive angle. It went ahead and opened, if you will. It opened and it went counterclockwise. If it goes like this from the initial side and it goes down, we're going to go ahead and say that that is a negative angle. And you can see that right here, I had a negative sign. Okay. So ideally nothing changes, just that the position of which you are approaching the terminal side, whether it is counterclockwise going up or clockwise going downwards. Okay. Okay, and let's go ahead and go with the next part. So the next part that I want you to know is coterminal angles. So if I was to show you this angle right here, hopefully you will see that. I'll make it in red. There is two ways to approach this, right? We can go the positive angle, which is from here to here, which I don't know, appears to be bigger than 180, right? Because this is 180, this is 270. Okay. So we can go ahead and say that's like, I don't know, 225. But on the other hand, it has a coterminal side, meaning the other way around, the negative version, right? This right here, the blue one. We can see that there is another version of this, and this will probably be the negative side of it. This will be the positive side of it. What I want you to know is that just by having an angle there, we can go ahead and approach it, the positive version and the negative version, and still these angles are called coterminal. So let's pretend this was, I don't know, 200. Then its coterminal would be the other way around, the difference of this right here. So it would be, it's freaking out here. I don't know. 180, what is this, 20? So it'd be all of that difference from here. I'm freaking out. Okay. Anyways, it's pretty much getting nervous here. All right, I'm gonna skip it. Couldn't do that mental math for in camera. So pretty much another way to see this is by looking at this right here. So let's say you have an angle that has gone more than one revolution. So hopefully by now you see that this angle went a complete revolution, and then went a little bit more, which is denoted as A. So this is probably like, let's say, I don't know, 400 degrees. That is for sure bigger than 360, right? So we're going to go ahead and see that it went the complete circle and a little bit more, because this is 360 if we do a complete rotation. So it went a little bit more. How much more? Well, we can say that this right here is just 40, right? 360 plus 40 gives me my 400. So we can see that 400 and 40 are coterminal angles. Okay, awesome. Alrighty, so let's go ahead and continue from here. What I want you to know is that there is a way to denote these little degrees, and it's with that little tiny circle. So the most common, angles, the most common form to measure angles is with degrees. I can't, right? Degrees. And it's denoted by that little symbol like this, okay? A degree is equivalent to what of a full rotation? Well, that is equivalent to one little tiny slice of an entire revolution. So it's going to be 1 degree out of 360 of them. Okay, so let's go ahead and try to sketch this out. So from here, I can go ahead and see that 60 degrees. What I do, guys, is I go ahead and label this as 0. This is 90. This is 180, right? Because each quadrant is 90. And then I add it, and they got 270. Then again, 360, right? A whole revolution. Okay, so if I want to go ahead and sketch this right here, I'm going to go ahead and see that 60 must land a little bit here, a little bit bigger than halfway through, right? So this right here from the standard position, right? The little x-axis looking type, it's going to be 60 degrees. Okay. Negative 120, don't be scared by that. We just know that now instead of it going like it normally did, like clockwise, right, in this direction, it's going to go backwards. It's going to go this direction. So what I like to do is I like to label this with 0. Now this is negative 90, negative 180, negative 270, because we're going the other direction, and then negative 360. So negative 120 appears to be landing in quadrant. Let's go ahead and label 1, 2, quadrant 3. So it looks like it's going to go right here from the standard position. Okay, I'm going to go ahead and draw it with a different color because it appears I have too much purple. So I have it like so, right? So right here to here, we can see that this is negative 120. Okay, How about 400? So go ahead and pause the video and try to determine where this angle will land. Okay, so we can see that 400 is bigger than 360, and we just happened to do the example here. That's probably why it was the first in my mind. So 400 minus 360, we can go ahead and see that the difference will be 40. So it's going to go an entire revolution, right? An entire. So I'm going to go ahead and represent that circle and a little bit more, just like that, where this right here will be 400 degrees. And that little coterminal angle, as we mentioned, was 40 as well. Okay. Alrighty. So I got a meme for us. Hopefully we can get to see some a little bit of snow. Okay. So what you up to? Making snow angles. Makes me laugh. Alrighty. The next thing that I want you to know is this right here. There are some common ones that you just tend to just memorize, but there's also a way you can figure this out on your own. So if you want to change from degrees, from degrees to radians, you need to multiply by pi over 180 degrees. If you want to change from radians to degrees, you do the reciprocal. You multiply by 180 over radians. Okay. So it sounds scary, it really isn't. Keep in mind this, I guess, identity, if you will. Pi is 180. So that's the reason you can do this, because ideally you're multiplying by 1. You're saying, oh, pi over pi, that's same term, right? Same on top, same in the denominator. So I can go ahead and reduce it, and I'll get 1 over 1, which is still 1. So that's the reason this works, even though they're two different things, right? So go ahead and pause the video and write this down. Okay. Alrighty, so let's go ahead and do some examples. And I have this right here. Convert each measurement to radians. So I'm going to go see what they gave me. Well, they gave me degrees, right? This little symbol tells me I got degrees. So I'm going to go ahead and get degrees. And I'm going to go ahead and change it to my radians. Oops, radians. In order to do that, I must multiply by, right? I want to get rid of that degree. So I'm going to go ahead and make sure I have degrees in the denominator, 180. And then therefore, the same thing, 180 is the same thing as pi. Okay, so that means every single thing here, to change it into radians, I must multiply by pi over 180. So let's do that. Pi over 180. Okay, so let's go ahead and simplify. I got 60 pi over 180. And I'm going to go ahead and multiply. Sorry, I blanked out for a second. So remember, if you want to go ahead and multiply fractions, we did this already. Multiply numerator times numerator, denominator times denominator, and I got this. Okay, so I have 0 divided by, I'm sorry, not 0 divided by 0. I have everything here is a multiple of 10, so I'm going to divide by 10 to reduce this. I know in middle school we probably just went with the zeros and did done, right? But keep in mind that all of this was just divided by 10. Okay, so I'm left with 6 pi over 18. Okay, now this number should be still divisible because 6 and 8 are even. But I think there's another number that we call also divide by, and that's division of 3 on both parts. So I should have a 6 divided by 3 that gives me, even better, we can divide by 6 right off the bat. The reason for that, because I just realized that we can divide by 6 to multiple of 6, so I'm going to divide by 6. And 18 is also a multiple of 6, hence the 3 that we were working with. Okay, so 6 divided by 6, I'm just left with pi. And 18 divided by 6, we can see that that is 3. Sorry about that. To re-record this video, making too many mistakes. Okay, let's go ahead and try the next one. I got 150 degrees, and I want to change it to radians. So I'm going to get my 150 over 1, right? Because I want to make it a nice little fraction. And I'm going to go ahead and see that I have a degree in the numerator. So I'm going to have 180 on the denominator and pi in the numerator. Okay, so let's go ahead and reduce this as much as we can. So I got negative 150 pi over 180 degrees. Okay, so from here, I'm going to go ahead and simplify by 10. So I got negative 15 pi over 18. Now, this right here, I'm going to try to simplify it more. So I'm going to divide by 3 because I think that's the only number that we can use because 2 won't work for the 15 and 3 will. So, and it also works on the 18 as we saw in the last example. So negative 15 divided by 3 should give me a negative 5 pi. And 18 divided by 3 gives me a 6. Awesome, awesome. Okay, last but not least, we have negative 360 degrees. Some of us already just saw from our notes that this is negative 2 pi. If not, you can do the exact same thing. So I got negative 360 times pi over 180. This should give me negative 360 pi over 180. This gives me, I can see 360. If I divide it by 2, I get 180. So that means 180 is a factor. So I'm going to divide everything by 180. So I'm left with negative 2 pi over 1, which is just negative 2 pi as a solution. Okay. Alrighty, let's go ahead and continue. These should be my last examples. So now we're changing the radians, right? Because I see pi's, so I'm changing radians into degrees. Okay, so let's go ahead and do the following. So in order to do that, we're gonna have to multiply now by the reciprocal, right? So it's, if I see a pi in the numerator and I'm trying to get rid of it, I should have a pi in the denominator. Does that make sense? You're ideally trying to get rid of the radians. And then pi is the same thing as 180, so that's what's gonna go over there in this proportion. Okay, so this right here times 180 over pi. So it should be a little bit more easier. So we can see that I have 180 pi over 6 pi. And if I simplify, right, the pi and the pi, they're like terms. I can divide by pi, they equal to 1. So this right here, 180 divided by 6, that should give me 30 degrees, right? Because we got rid of the radians, so therefore all we're left with is degrees. I know a lot of students want to cancel those things out. Keep in mind, those are the units. We cannot do that because they're not the exact same unit, you know? Okay, let's go ahead and pause the video and give these two a try. So I have this right here, 180 times pi, because I'm trying to convert, so I must multiply by this. And if you ever forget this, just keep in mind, if you have a pi in the numerator, you should have a pi in the denominator. Okay, so I have 3 times 180 times pi divided by 2 pi. Ooh, that looks very, very messy. What I want you to know is we can go ahead and simplify the pi's first. Those won't be a problem. But 3 times 180 is a pretty big number. I'm going to go ahead and use my property. So I'm going to go ahead and use 180 divided by 2 just to make the multiplication easier. I'm sorry, division easier. So I'm going to get that 180 divided by 2 is 90. So we have 3 times 90 over 1, right? Because the 2 got reduced as well. So we're left with 3 times 90, which is 27 times 10, which is 270 degrees as our solution, right? The last but not least, we're going to go ahead and do the same thing. So negative pi over 4 times my 180 over pi. Keep in mind this is negative. Don't forget your negative. Okay. So from here, I got negative pi 180 over 4 pi. And we can go ahead and simplify. And we got negative 180 divided by 4. So if you don't know that one, you can go ahead and just go back to your basic division, guys. You don't have to go ahead and do a lot of mental math if you just want to go ahead and do the algebraic. So you could also think about it, 180 divided by 2 is 90, and then 90 divided by 2 is 45. So this right here gave me negative 45 degrees. Okay, awesome, awesome. Hopefully this made sense. I know I took it really slow, but sometimes that's just what it takes, especially if this is an introduction to a new unit. I did go ahead and made an exit ticket for you guys to go ahead and practice, and that is due today. If you do have questions, please reach out to me, and I'm here to help you out the best that I can. Other than that, guys, have a good day. And as always, it's been a pleasure, and thank you.